This question we are asked, which type of bond is present in this molecule, this ammonia, all right? Which type of bond? And we have a range of options. So we have ionic, covalent, dative, and what? Metallic. Now I'm going to illustrate all of them to see the kind of bond that is present in this molecule. Now, for ionic bonding, or you call it electrovalent bonding, is ionic or you call it electrovalent bonding, is a type of bonding that involve metal and non-metal. In this one, the metal will always transfer its electron to what? To non-metal. You get that? And the metal that will transfer electron, it means that it lost electron. And those one that will, the non-metal that will receive the electron, it means that it gains the electron. You get that? For example, we have sodium and what? Plus what? Chlorine. All right. Now, sodium here has one lone pair electron. Now, sodium here has what? Has one valence electron. Sodium electronic configuration is what? Look at the electronic configuration of what? Of sodium here. Chlorine, on the other hand, has what? 287. 287. That is, the first shell is 2, second shell is 8, third shell is what? Is 7. Now, chlorine needs 1, so that all of them want to be like what? The noble gases that have what? A complete valence electron in their shell. That is to obtain an octet configuration. All right. So now, sodium here, look at chlorine here now. 1, 2, 3, 4, 5, 6, 7. Chlorine needs 1 to complete. Therefore, sodium here will not give out chlorine 1. Do you understand? Will not give out chlorine 1, so that this one now, it will not remain what? 2, 8, which is what? The 8 is what? Is for the octet configuration. On the other hand, chlorine here receiving 1 from here, it will not complete what? It will not complete 8. Do you understand? We now have something like this. Sodium. That is how the bonding is. And at the end, we have what? H. You have something like this. This is sodium, and this is what? This is chlorine. That is kind of bonding is what we call what? What we call ionic bonding. Sodium transfer, and sodium that transfer, it has what? Lost electron. If you want to write the equation, will be what? Na plus what? Electron will give what? Na. This one is what? Non-metal. So it is, this one involve metal and what? Non-metal. Now, in the case of covalent is a type of bonding where element or atom share electron equally. You get that? It's a type of a chemical bonding that involves the share pair of electron equally. Now, in the case of covalent bonding, it's a type of chemical bonding where an atom share equal electron. Do you get that? They share equal electron. For instance, now hydrogen has what? Hydrogen has one valence electron. Another hydrogen has one valence electron. So see, this one has one valence. This one needs 1 to complete. This one what? Needs 1 to complete. That is 1, 1. Both of them need 1, 1 to complete. So 2 of them will now join themselves to form what? To form H. Do you get that? That is where we now have what? Hydrogen gas. 2 of them will now form to form what? To form a complete octet configuration, like in the case of what? The case of helium. Another example can be seen in chlorine. Chlorine plus what? Chlorine. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Now, chlorine needs 1 to complete. Another chlorine needs 1 to complete. So 2 of them now will now bond to give what? Cl. That is why you now see what? Cl2. Do you understand? Now let's proceed to dative bonding. A dative bonding is a type of chemical bonding where one atom donates electron to another one, but both of them will not share the electron. Do you understand? One atom will be the one to donate, then both of them will now share the electron that one donates. One will accept while one will what? Donate. It's different from what? From ionic. All right. In case of in dative, one donate to another one, both of them will now share. Example is found in this ammonia. Ammonia, we have what? Ammonia, we have NH 1, 2, 3, 4, 5. Do you get that? Now, hydrogen, on the other hand, we have 3 atoms of what? Hydrogen, which will be what? Which will be H, H, and what? H. Now, this H here, hydrogen has 1, hydrogen has 1, hydrogen has 1. Now, this one that will be here, we'll take it to this one, so that here will now cross to this side. Here, we'll take it to what? Take it to this one, so here will now be what? Cross to this side. Now, here will now take the place of this one. You can see that, look at how ammonia is here. Are you following? But now, ammonia will what? Will require another hydrogen to form what? To form ammonium. Plus what? Plus hydrogen. Do you get that? So that they will form what we call NH4. Now, but remember, hydrogen here has what? Has 1 valence electron. And here is already complete. There is no way you can come and add here. What it will do is that it will what? It will lose electron. It will remove this electron so that both of them can combine together. If you now remove this electron now, look at, if you now remove this electron, we will now have what? Something like this. H, 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 H. Do you get that? Now this one has been what? Has been removed. This plus here means that lost electron, so it will be removed to form what? To this one will now, this hydrogen now will now come and attach itself here. Do you understand? Because of what? It has lost 1 electron. Do you get that? So therefore, we now have our structure as well, NH4. So this type of bonding is what we call dative bonding. Ammonia here donates 1 what? 1 electron. Since it donates 1 electron, ammonia here donates electron. Hydrogen receives the electron. You get that? So both of them now form what we call what? Ammonium. That dative bonding. In the case of metallic, so our answer is what? Our answer is dative. It's commonly in what? In ammonia to ammonium.